right. Hello, everybody. Welcome to this webinar. We're here from with a small group in Helmond at the Automotive Campus, and we will be hosting you for today. A couple of the presenters are here around me physically, of course, with great distance, but we will do this webinar, of course, online about heavy-duty battery development. I am Rutger van Poppel, working for Brainport Eindhoven region, a region high-tech ecosystem in the southeast of North Brabant, one of the provinces in the Netherlands. I will be your moderator for today. We'll introduce the speakers. We have several speakers from that are representing the national markets, both from the Dutch side and the American side. This will be very interesting to elaborate and see how both countries are active in green mobility, especially on the heavy duty segment. And we will have some companies from both countries that will go a bit deeper into what they do and what technologies they are developing to accelerate the energy transition. So I'm very excited to explore the synergies between both countries, and perhaps we can develop some very interesting relationships for the future. I want to start today with one of the ones that we work very closely with, Gerard Koning from RAI Automotive NL. He will tell a bit more first on the Dutch battery ecosystem that we are developing. So now I would like to give the word to Gerard, who is sitting next to me. And the floor is yours, Gerard.
Thank you, Rutger, and good morning, America, and good evening, Europe. My name is Gerard Koning. I'm manager of Green Mobility within the Royal Dutch RAI Vereniging, which is representing the automotive industry in the Netherlands. That's on national level and, of course, on international level. The topic of today is a battery competence center, which we are developing in close cooperation with Brainport, as Rutger just mentioned. Next slide. So again, we are a cluster organization and we are focused in the Netherlands, a small country, but we're doing quite okay in the terms of development and innovation. And we represent the Dutch automotive industry. We work in a triple helix. That means we connect industry, government, and knowledge centers. We stimulate innovation by creating corporations and innovations within the industry, and we reinforce and facilitate. That means we share and develop knowledge in the field of automotive technology and related aspects. Next slide. Our areas of expertise are four main pillars. That means we have green mobility, smart mobility, manufacturing, and materials. And we look for the 3 zeros, the zero emissions, zero congestion, and zero accidents. Again, today I represent green mobility, and the aspects are within the field of innovating for zero emission mobilities. Next slide. Our community has some 200 plus members. We have a digital community which is larger, but 200 active members which are spread in the total field of services within the automotive industry. It means we have OEMs, but we also have tier 1, tier 2, and tier 3 suppliers. We have knowledge centers attached, and we have regional or national governmental parties as our members. And altogether that creates a field of players which, by supporting and helping and co-developing with and together with the RAI community, creates the automotive innovations of today and tomorrow. Next. Some examples of the electric buses and trucks. As we talk about zero emission vehicles, of course, besides batteries, there's hydrogen, there's e-fuels and other options, but today the electric vehicles. Here in the region, the Brainport region, and we are located in Helmond, but in Eindhoven, a larger city, very close, like 10 kilometers, there's the factory of DAF, which is a Packard company. There's the factory also of VDL, still private-owned family company. We've done lots of development for passenger cars and public transport. We have a picture of left corner below, a picture of the first crane truck here in Europe. Then in the middle, there's a picture of a garbage truck. The operational experience is being explored since more, let's say, 2 months. And we have some demonstration programs for that to see what the inner city transport and then on heavy duty can profit from. The other pictures are pictures of charging systems, of course. Electric buses need their power source from somewhere. And in this case, it's on rooftop level where the pantograph charges the vehicle. Next slide. So this battery competence center we're talking about today comes forth from a European climate agreement. From that, Dutch ambitions are appointed, and we have some industrial sectors that need to be involved for that, which means the contributor to reduce the carbon dioxide footprint are within the automotive industry, so heavy duty trucks, ships from maritime, and planes from aerospace, and not the less party to be involved, the electricity companies that provide the power grid in order to charge those batteries. So we're looking at carbon dioxide footprint reduction, sustainable technology, social responsibility within the production of those batteries, and the availability of products. Can we get the battery of the future when the future is coming from outside of our control? What we have in the middle is a bit clockwise, the picture how the battery has a life cycle, and we want to create that life cycle as a circular economy product, which means nowadays from the mining the raw materials come, lithium, cobalt. Lithium therefore has to be transported by ship, cannot be transported by plane. That ship also contributes to the carbon dioxide footprint. Cells are produced, again, bring them to Europe, to the Netherlands by ship. And then we have the assembly of a battery package, the first OEM truck, ship or planes that use the battery, the people that drive those products. And then it comes back and we'd like to reassemble them for their second users. And those second users can be either trucks, can be supportive for the power grid, or other purposes. And in the end, of course, we recycle, and then we have the pieces of raw material that are remaining. And we are very interested in the gray parts, making the gray parts green. That means we are looking for new technologies which are contributing to a better environment in the circular life of the battery. Now for that, together with Brainport, we have initiated the Battery Competence Center, which also includes a field lab and an assembly plant in order to elaborate on the future batteries. And we bring in again the triple helix, the knowledge, the government and the industry. And from the industry, DAF, which is a Picard-owned company here in the Netherlands, VDL for the buses, and Damen Shipyards, which is again a ship builder. We all contribute to that. In the future, other parties will be joining, can join. They don't have to be national, they can also be international, of course. But this is a startup in order to create a circular economy. Next. So what we focus upon is on the left side, creating a package of requirements. What do we want this battery to comply to? And on the right side, we want to design for sustainability. That means we design, we use and reuse and we recycle. But as someone told me, it takes more time to take out a battery out of a phone than to recycle him. We want to take all those parties in one development round, and gather all their needs within their own processes into the design of that battery of the future. And the goal for that is to reduce the amount, of course, reuse materials, and in the end, recycle in a sustainable and responsible manner. Excuse me. Next slide. So what's this battery again for? At the left side, you see the smart chargers. Some people had an electric car, they charge, and before you know it, it's a lot of people. Then we created some home chargers, so you don't have to go to a charging station. We connect the solar system to it, and people have one or more cars. Then the charging hubs came to speech. Bidirectional charging came, and then we have the grid support, because the grid now becomes so big with peak moments that for those peak moments we need some solution, and that could be indeed the battery, which will be used during the peak moments and will be off during the normal operation hours, where all people are at work and the power consumption is less. What we don't want is all those batteries coming from those users to be sold by somebody we can or cannot trust. So we want to have a vehicle independent, and that's important, health check, which tells you how the battery is performing and how we can trust that battery for the next use. Without that, we would be depending on the battery as part of the vehicle. And of course, you can't claim the responsibility of the performance of a battery from an OEM if it's used for grid support. So that vehicle health check is important to us. Next slide. With that, and we have, of course, to elaborate on options, possibilities, technologies. We have items as cybersecurity, as BMS systems, software, hardware. And with having said that, we want to create that community within the Battery Competence Center as one of our programs. And anyone that has questions, I can answer, or be my best. Back to you, Rutger.
Thank you very much, Gerard. Interesting to see. So everybody that has questions can ask them in the Q&A at the bottom of your Zoom screen. So please feel free to throw us any question that comes to your mind when during the presentations as well. Then I will be able to guide them to the speakers or the ones that they are meant for. For now, I have a question myself to Gerard. So, Gerard, let's say that an American company or a representative from the industry would like to develop his, get in contact with the Dutch ecosystem. How can you assist them in that?
Yeah, thank you, Rutger. Thank you, Bryce. Name makes me think that you're in Europe, but again, of course, there's now a check when you go to the garage. They tell you how your car is fit for using it for another year. Within the Netherlands, that's called an APK check, but that won't tell you anything of the performance when you leave the garage. What we would like is to build the trust for the electrical vehicles, where the battery takes a large part in the cost, in the amount of money you have to pay for that. So if you do that and you drive away and the battery would be bad and you need to invest, let's say, 50% of the value of the car, that would be bad for having a second life and having the acceleration of the introduction of electrical cars. So garage holders, the people that do the governmental checks on cars, but also the users of the power grid, they can use that battery if they know that the performance of that battery is suitable for their purpose. And of course, we need standardization, protocols, software, etc. But that's a discussion that needs to be on European or even on international global level.
Perfect. Thanks. Hope this answers your question, Bryce. Thanks also for asking the question. I think it's interesting to see that with regards to how this is organized, that you see that multiple companies work together in an ecosystem to provide a system solution. We will also hear more about that later on from Heliox, who was part of one of these great developments here in the Netherlands. Again, I just asked you, Gerard, and you answered Bryce's question, but what can you do as a branch organization of the Dutch industry for American companies that are interested to get in touch with that network or develop a relationship with the Netherlands?
Yeah, well, we typically are an organization representing the automotive industry, so connecting parties with our members and having discussions and programs around that, but participating in that. Of course, everybody for that matter is welcome, but we think we can provide some front-runner technology. We have quite some discussion that leads to a certain description of the standardization. And we even have some technology already in proto phase that would be suitable to provide the function of doing that health check. Now, for the matter of the connection with the US, we can support you in your discussions, conversations with governmental parties by providing the information that we already have together with our government.
All right, perfect. So that hopefully and should guide the people that are interested to us. So also feel free to contact us after this webinar for these kind of topics, and we will guide you towards Gerard, who is then of course happy to help. A leap to our next presenter, that will be Anthony from the California Energy Commission. First, Gerard, what do you think that is the difference between the current ecosystems of the Netherlands and America?
I don't think that I don't think there's so much difference. The reality tells us that the European trucks are a bit smaller than the American trucks, but nevertheless for smaller trajectories, so shorter ranges, for inner city transport, for the social needs that are within the cities in Europe, they will also be in the cities of the US. It's a matter of volume for that matter. Performance can be built by combining multiple batteries for larger users, but in principle, I think we all have the same issues, the same challenges, same innovations. The only difference is that, well, like some 10 years ago, within the Netherlands, the initiatives were already taken by the industry before the governmental demands were announced. So we have quite some good front runners here. All
right, thank you, Gerard. I think that is a perfect link to what Anthony will tell us now. Anthony, the floor is yours. Anthony from the California Energy Commission. Please unmute yourself, Anthony, when you start talking.
Okay, great. Well, thank you very much, Ricard. And thank you, everybody. Good morning / good afternoon. I appreciate the opportunity to share about our experiences. My name is Anthony Yang from the California Energy Commission. I work in the Research and Development Division. Just to start off, just a quick background for folks who may not be familiar with the Energy Commission. We are a state agency here in California. We are the state's primary energy policy agency. So we set and enact energy policy. And the big drivers these days for climate and energy goals are, we have here in California, we have a goal of reaching 100% clean energy grid by 2045 and trying to get to 80% GHG emissions below 1990 levels by 2050. So those are two kind of really big high-level targets that that's is in the background for much of what we do. And so when we talk about achieving these goals, it's going to require obviously a significant transition in the way we generate energy and use energy and the way our economy works. Going into that transition, a big priority of the Energy Commission is also that the technology solutions, the transition applies to everybody, right? Including the folks in California that from disadvantaged or low-income communities. We always have a priority to keep those individuals in mind and those communities in mind to make sure that they don't get left behind in the transition. And of course, ensuring that our energy grid remains reliable and resilient. Unfortunately, here in California, over the last few years, we've seen kind of increasingly severe wildfires have pretty devastating effects, both on kind of property destruction, but also on energy. And so we want to ensure that any transition into a clean energy future also enables, maintains reliability as well. Next slide, please. So within the Research and Development Division, we are focused on creating market and technology solutions to achieve our energy and climate goals. And so within that kind of high-level mandate, we have a pretty broad area of focus in terms of the types of technologies and the topics that we cover, from efficiency, controlling load, renewable generation, storage, transportation electrification, which is the focus of today's discussion, as well as kind of the scientific research and modeling for understanding how climate change is going to affect California here. Next slide. So just getting a little bit more specific within the Research and Development Division, we operate several programs, and our kind of primary vehicle is grant funding. We fund and manage grant researchers to develop technologies and market solutions. The primary program is the Electric Program Investment Charge, also known as EPIC. It's a $133 million program that we manage, and I'll be giving a couple of examples of that portfolio of investments for the rest of my talk. But a couple other programs that we have: natural gas research. This is similar to our electricity research. It's just on focusing on natural gas. We have a food production investment program. This is less research and more focused on essentially targeting the agricultural and food production industry, a big industry in California, and getting them to switch their kind of industrial equipment from natural gas or to more efficient or electric solutions. And then we have a low carbon fuel kind of biofuel production, relatively smaller program. Next slide. So with a little bit of background out of the way, I'll spend the rest of the time just kind of giving a few examples of specifically the transportation electrification portfolio of research that we're doing here at the Energy Commission under the Research and Development Division. The first area I'll cover is battery component research, right? So as we discuss transportation electrification, the desire for increased range and increased safety from the vehicle's perspective is ever increasing, right? Both from market demand and also, when you think about the transition from single family or passenger vehicles to medium heavy duty vehicles, the need for greater energy density and power is going to be increasing. And also, the industry as a whole is looking for ways to increase their performance while reducing costs. For example, also kind of moving away from elements like cobalt, which has had some challenges in terms of sourcing from kind of not so great places in the world. And so this is a couple of examples. We have 3 companies here that we're funding: South 8 Technologies in San Diego, Qberg in the Bay Area. These 2 companies are developing new electrolytes that have been kind of at least at small scales have shown the ability to increase energy density, performance, and safety. And then Stepion Technologies, also in the Bay Area, is developing a membrane. And so these 3 companies are developing components within a battery that we think could serve as really good platform technology. So as battery chemistries, lithium-ion chemistries change and differ depending on kind of different performance, we feel like these technologies can then are in a good position to integrate into those technologies and add increased performance. So all 3 of these companies have shown promising small-scale demonstrations, and our projects with them are really helping them scale the production of their specific component, as well as integrate into existing battery manufacturing lines. Next slide. So next example is less of a technology solution and more of a market solution, right? So this project is really targeting fleet managers, both corporate and government fleet managers, which have the responsibility of kind of purchasing and operating, thousands of vehicles throughout the state. And the goal here is to give them information, additional information, so that when they are making their next purchase decision for their fleet vehicles, we're hoping to encourage them to choose an electric vehicle as opposed to a traditional internal combustion engine. And so how this product works, called My Fleet Buy, developed by a company called Greenlight Labs, it leverages advanced physics modeling and vehicle modeling developed at Lawrence Berkeley National Laboratory. And it's an app-based program. A driver, turns on the app, they put the phone in their car, and they go about their normal route. So whatever that fleet vehicle does, deliveries, services, maintenance, whatever they do. And so as the driver and the vehicle is driving, the app is recording information about the vehicle. So not just the route, but also how the vehicle drives, the acceleration, the kind of the behavior of the driver. It then compares all that data to the vehicle that you are driving, your internal combustion engine, to a hypothetical electric vehicle that you might be interested in. And then so it gives you essentially a virtual test drive. It says, this is your actual route, this is your actual duty cycle, and this is how your patterns would compare if you had taken that same route and that same duty cycle with an electric vehicle, showing both range, mileage, as well as things like availability of charging stations and pricing of charging as well. So again, this targeting fleet managers, hoping to give them enough information so that when the opportunity comes and that they are in a position to procure large amounts of vehicles, that this gives them enough information, enough comfort, so that they make the switch to an electric vehicle. Next slide, please. So next example, we can't talk about vehicle deployment without talking about the charging infrastructure, of course. And as California is looking at mass deployment of electric vehicles, we have a goal of 5,000 electric vehicles on the road by 2030. From the grid implication, the amount of vehicles could either be a liability or an asset, right? If left unmanaged, the charging could become a detriment to the grid. It can create really uneven charging patterns throughout the state, and really tax an aging infrastructure, especially in really congested urban areas like Los Angeles or the Bay Area. And so we are.
Left, Anthony.
I'm sorry?
2 minutes left for you.
Okay, thank you. Yeah. So we're looking at solutions to help do managed charging, right? So this is a project with ChargePoint. They've developed a networked charge infrastructure that can both communicate with the grid. So the grid can send dynamic signals saying, when the grid is taxed or when the grid is, less taxed, and it can send a price signal that then can be transitioned to a customer who can make a decision on whether now is a good time to charge or not. So they plug in, but they don't necessarily have to charge, right? I think the good thing about vehicles is that most customers don't care about when they charge. They just care that at the end of their, kind of the time that it's charging, that they have, the vehicle, the enough miles to get them to do what they need to do. So there's a lot of flexibility of when the charging happens during the time. So we can use that time to manage the load and respond to grid signals. Next slide. And then my last example here is towards the end of last year, toward the end of 2019, the Energy Commission just started a $75 million program to replace a lot of the old school buses in California. This is less of a research program and more of just straight replacement program, focusing on GHG emission reductions, targeting the oldest and dirtiest diesel buses throughout the state. Hoping to get to about over 200 EV buses throughout the state. Kind of the kind of interesting thing from my perspective from research and development is that all the buses have to come equipped with both vehicle grid integration and vehicle to grid capabilities. So vehicle to grid integration, kind of more of that managed charging, like the last slide, but the vehicle to grid capability is really interesting, having that ability to bi-directional charging. So the vehicle can not only charge from the grid, but also discharge to the grid if required. So since we're going to have so many school buses deployed to the state, it's going to be a really interesting potential for research platform. for us in the future. Next slide. And then just I'll leave with, if anybody's interested, we have a new platform that we just launched called empowerinnovation.net. It's got a lot of resources. It's got all information about a lot of companies in our community. And it's a platform that we've started to help kind of connect different members of the stakeholders around funding opportunities that the Energy Commission provides for clean energy development. So, for more information about, some of our programs and the funding opportunities available at empowerinnovation.net. Next slide. And yep, and yeah, that concludes my presentation. So I'll turn it back to you, Rooker.
Perfect. Thank you, Anthony. Very interesting to see this other side of the story after we saw Gerard's presentation on the Netherlands. It's interesting to see two similar organizations developing their battery ecosystems and pushing towards green mobility. And we already have one question from Arjan van Vliet. He is asking you, Anthony, what's the percentage of EVs in the state of California, and how many charging points are available, public and private? Could you elaborate on this?
Yeah, so unfortunately, I don't know the precise numbers, just kind of off the top of my head. I do know that the majority of electric vehicles sold in the United States are sold in California. So California definitely has a disproportionate share of the market for electric vehicles, passenger electric vehicles primarily. And I know, so the Energy Commission operates a program called the Cal-E-VIP. So that resource, Cal-E-VIP, has information about all public chargers available in the state of California. It doesn't have information about private chargers that a homeowner might set up at their own residence. But Cal-E-VIP has information, kind of availability of public charging infrastructure in the state.
All right, thanks for the elaboration, Anthony. And now another question comes in, great, from Bryce van Vlijmen again. Hi, Andrew. Are there any Californian initiatives on battery pack reuse and second life use?
Mm-hmm. Yeah, there are. So just recently, actually, I say in the last 3 months, the Energy Commission just awarded, I want to say 3 or 4 projects researching exactly this, both battery diagnostic, kind of, algorithms and other methods to do battery health checks on battery packs. Because, the challenge with reuse is that, when you get a battery, you don't really know how the battery's been treated, so to say. And so it's hard to get accurate information about how that battery could be repackaged or reused either for another vehicle or for stationary use. So we're funding a couple of projects doing kind of advanced software to do better battery diagnostics, but also a couple of projects doing battery, the physical, collection and kind of, aggregation of battery packs to repackage battery modules. So that is something that the Energy Commission from R&D has funded.
All right. Thanks. Hope this answers your question again, Bruis. I'm also interested, Anthony. So, from the Dutch perspectives, it seems that Dutch companies, if they look at the American market, that for green mobility, California is the place to be. Could you put that in perspective for us? Yeah,
I mean, mobility is a huge portion of California. If you think about just historically, a lot of the clean air regulations that were passed in the United States were really kind of started with pollution difficulties in the Los Angeles area, right? The population density in the Los Angeles region is some of the highest in the country, outside of New York. But the kind of the market for mobility is huge in California, and then couple that with really I would say a really positive policy environment in both in terms of goals of electric vehicles, the state incentives available. I think e-mobility in California, if you're trying to get into the United States market, like the the California market is you know the single largest, absolute, you know, by far, and you know, kind of the place to be.
Perfect. Okay, interesting to hear. So it seems that especially the mindset and the open mindset and innovation culture of the Netherlands and California are alike. So that should be something that the companies in this webinar should explore further, I think. Through to the next presenter. This is one of the Helmond and Eindhoven growing startups, very interesting battery company. Bas Verkuyk will present us about their modules and battery packs. And I will give the floor to you now, Bas. Please unmute yourself.
As Rutger mentioned, my name is Bas Verkuyk.
There you are.
Huh?
Yeah,
you
were a bit delayed, but I can hear you now. Yeah, please go
okay,
ahead.
perfect. Yeah, so yeah, my name is Bas Verkuyk. I'm the co-founder and also CEO of Spike Technologies. And as Rutger mentioned, we're based at the automotive campus in Helmond, which is in the south of the Netherlands. And as the subtitle in this presentation already suggests, we make high-performance batteries for various electric vehicle applications. Before I will tell you a little bit more about that, first a little bit more about our history. So if you could go to the next slide, you can see one of my holiday pics in an environment that of course looks familiar to all of you. Because as a company, we originate from the Eindhoven University of Technology, in which we did a project in which we built this revolutionary electric motorcycle completely from scratch with a modular swappable battery pack that gave it a range of about 400 kilometers. And to prove the potential of this vehicle and also of electric vehicles in general, we drove it around the world in 80 days. And of course, we also passed by the beautiful San Francisco. And after this adventure, which is already about 5 years ago, we decided to continue with the development, with the technology we developed during this project, and especially the battery technology. And we started Spike with the aim, with the vision to make high performance, high energy density battery packs available to various applications. As you can also see on the next slide, a few examples. And of course, to make such high performance battery packs available to various applications, the design objectives are quite different from the design objectives if you look at passenger car batteries. Especially due to the different scale of production, of course, of these applications. So if you could go to the next slide. Yeah, of course, in a way, the design objectives are also comparable because, of course, what we also want is to bring the highest possible energy density to our customers, as this enables them to design machines that last longer on a single charge. While we also really want to ensure the maximum performance, safety, and also lifetime for these packs, which is of course very important, especially when working with these high energy dense cells. But the difference here is that we really need to be very flexible because yeah, we should be able to keep the investment costs as low as possible, as this will also make the machine costs low due to limited scale of production of our customers. So yeah, what we did is we designed a unique modular battery concept, of which you can see a picture on the slide. And it's based on the previous one still, sorry. And it's based on cylindrical battery cells, so both in 18650 as well as 21700 format. And this enables us also in combination with the minimization of parts and the elimination of wires, cables to reach a very high energy density of up to 250 watt-hour per kilo on module level. But besides the energy density, I think what's really important in designing such a battery pack, also battery pack in general, is how you manage the battery management system, the BMS, but also the thermal management, as it will really make the difference in terms of the lifetime and also the safety of this pack. Yeah, here's how we did that. So we actually, yeah, we have a unique production method which enables us to make the electrical cell connections on one side of the battery pack, and this means we can directly connect the cells on the other sides to a cold plate, which also acts as a thermal interface. And this ensures that the cell temperatures are extremely balanced at all time. And this is really important for the lifetime of this pack, to increase the lifetime of this pack. But it's also a safety buffer when there's a very unlikely event of thermal runaway, for example. It will act as a thermal buffer so the heat from one cell does not propagate towards other cells. So you will not have an unsafe event. Well, yeah, this safety, this reliability is also further strengthened by the battery management system, which of course also acts in case there is something dangerous happens. And also the algorithms we use on this BMS, it optimizes the lifetime, the safety, but also the performance of this module for specific applications. So based on the specific applications, operating temperature, but also discharge and charge rate, these algorithms can automatically optimize the performance and the lifetime of these packs. Yeah, finally, what's very important, of course, like I already mentioned, is the flexibility. So that's, of course, also the difference when you look at the automotive packs, for example. And what we did is we made a modular system. So we can optionally integrate a liquid cooling plate, very lightweight, compact liquid cooling plate, which we can attach to this thermal interface. And then, it can be used to actually make a more optimal operating temperature range for this battery pack.
We have 1.5 minutes left, Bas.
Yes, and also as you can see, we use these internal bricks, which enables very flexible module sizing. So if you go to the next slide, you can see that we can easily increase or decrease the module length, in which we can stay the same 48 volts system to make all sorts of packs optimally to our applications requirements. So as you can see on the next slide, we can connect these modules in any orientation towards systems that go up to 1,000 volts. But it can also be configured in different formats, in different capacities, really depending on what the application needs. And the configuration happens automatically, while we also integrate additional functional safety features into one master ECU, so one PCB that will act as a direct interface to the vehicle controller. So it really is a plug-and-play system for different applications. So you can see a few examples on the next slide. So as you can see, it's quite diverse. It can range from small wheel loaders to bigger excavators, so 600 volts, but also 50 volts, and from racing cars towards motorbikes. So if you're interested, I can of course provide some more information. So you can see my contact information on the next slide. So back to you, Rutger.
Thank you very much, Bas. Very great presentation, and it's good to see that these companies like yours and startups are growing so much because of the value that you offer to these companies of niche vehicles that we saw a slide earlier. We go to the next presenter right away. After that, we have a small Q&A again. So please ask your questions still in the Q&A section. But we go to Bob Bauhaus now from Heliox charging company here from the Netherlands as well. Bob, the floor is yours. Please unmute yourself.
Yes, sir. Thank you very much for addressing this. And Anthony and Bas, great presentations, very interesting, and thank you very much. I'll keep it very shortly, and Roger, if you could skip to the next slide, then I'll take you very shortly to a short introduction of Heliox. Started out in the Netherlands, but currently based in Portland, Oregon. We are headquarters US, and the production facility based in Minneapolis. We are currently world-class leader in heavy-duty powertrain charging. That means different modalities of vehicles. So if we quickly go through next slides, that means that we will be targeting buses. This is an example of 100 buses. Driving in a 24/7 operation, fully electric, articulated 60-foot buses in Amsterdam Schiphol Airport. This is a perfect example, for example, where the Californian culture matches the Dutch culture, where Anthony, for your information as well, that we are in a very good conversation with LA Metro. Exactly pursuing this path, and representatives have visited the location. if you go quickly through the different 4 slides, then you will see other modalities like automated guided vehicles here in Singapore, mining vehicles indeed. There we have got trucks manufactured out of this region and owned by PACCAR based in Seattle. Ferries, this is a picture actually from Copenhagen, Europe, and I think there's a last slide on modality, and that is, yes, autonomous vehicles. We just talked about smarter grid. Well, this is on the other side, autonomous and smarter vehicles, and these two worlds will meet very soon. And in this, well, we call it a niche, heavy-duty powertrains, but I think it is one of those modalities like electric buses that has the highest penetration rate of electrification worldwide scene. So this is a rapidly moving industry, and we're happy to be part of that. Next slide, please. So just to give you a bit of an overview, to connect and to do smarter charging, you have to be very good in partnering with larger partners on the vehicle side, at least for us. There's an overview of 27 OEMs that we are partnering up, including the larger OEMs active in the US, Proterra, Novabus, New Flyer, but also powertrain providers like Cummins and Allison. Next slide, please. On the back end side, we are connected with various smart charge V2G operatable back offices, including the Mobility House based in the Silicon Valley, but also Nuve based in San Diego, enabling us to communicate with vehicles and supporting the grid, including a V2G capability. Next slide. Some references, I think we can skip those fairly quickly. This is Oslo, Norway, 60 buses, basically explaining that you need to be interoperable, which is seemingly straightforward, but quite hard to have interoperability for our example with 27 OEMs in this quickly developing world. Next slide, please. And even up, this is actually the largest opportunity charged fleet worldwide, which is existing of 164 electric buses, consisting out of 3 bus brands, and all of those being charged by Helix. Next slide. Some examples in the US. This is Allison in Indianapolis. So opportunity charging is happening in the US at many of the factories of the OEMs, including this one. Next slide. And this is actually being commissioned at this moment in Chicago. This is a famous location in Chicago, the Navy Pier, where we will be quickly charging Proterra buses. I think it's about 20 buses in total, 5 systems out there being commissioned at this moment. Next slide. So introduction a little bit on standardization on interfaces. As we know, all CCS, picture this is CCS2, but pick a CCS1 for that as well. You've got opportunity charging, which is more or less stating 300 kilowatts, 450 kilowatts, or even 600 kilowatts that we are charging vehicles with. Also, all focused on minimizing the layover time and using the operational time of these commercial vehicles. Next slide. Some products, we can skip that for this moment. So if we can skip to another slide. Yes, please. So some smarter charge examples. I think we all understand that infrastructure is expensive, not only the equipment itself, but it is also a significant investment to connect that to the grid. So on both sides, it is quite a hurdle to take to enable e-mobility and electrification. So you have to come forward with smart concepts like smart charging, but also how we can use chargers or the same investment in infrastructure in multiple ways. For example, this is a good example where you have an opportunity charge of 175 kilowatts. Electrify America, for example, uses this kind of kilowatt fast chargers. But this charge can split itself up into 3 separate charges that you can actually charge overnight. These heavy vehicles like trucks, Class A trucks, with 60 kilowatts. So double uses of the same investment. Next slide, please. So, and more or less that comes to the closure of my talk today, is that I think we have seen the last 5 years that we all have been focused at getting this e-mobility process gaining some momentum. And I think we've succeeded as a group here today again in doing so. The next step is up to actually see it as just a piece of the puzzle, meaning that a vehicle is actually a battery storage and a charger is not just a charger, it's just a link to the grid. And with for good example, Anthony again, is the duck curve in California, creating huge problems to actually enable PV and wind power accessible to the grid. I think we can play a key role in this industry, including Bas, also your batteries, in stabilizing the grid. Because if we are able to invest in, for example, a good example, Tesla power packs or stationary battery packets, and of course those come with an investment, then we definitely can use those same battery packs and the same infrastructure we have in place, but paid for by public transport authorities, because we call it the bus with a bidirectional charger, or Anthony, as you mentioned, the school buses initiative, similar. So using the same investment, call it the vehicle, we call it the stationary battery pack on wheels, and then this momentum goes. So that's where the next step is, and we call it VPP, and many of our partners in this industry call it the same. So I think we're down to my final slide. This is a product in development where it all comes together, where it is a charger with for us a limited capability of a capacity of 150 kilowatts connecting to the grid, but enabling opportunity charging to operators, fleet operators of a maximum of 450 kilowatts. Obviously, there's a battery inside to enable that sprint, as we call it. But once that the charger is there idling, because there's no, in this case, bus being charged, then we can do enormous amount of fun stuff with that, including energy arbitrage, ancillary services, demand response, and distributed energy resources. So as Helix, we've got our products in development and are very eager to work together with our partners in California to access to pilot programs that we actually can put these products and concepts into place when V2G, for example, is fully regulated by law, and I believe that is in 2020 to be happening. So it's going to be a very exciting year. I think everybody agrees it is already a very exciting year worldwide, but on V2G definitely there are many things to happen, and recognize California definitely being one of the leading examples, but definitely across the states there are many other good examples to mention with school buses in the forefront on V2G. Thank you very much.
Thank you, Bob. Great to hear this story from a company that already has a significant amount of experience in the US and also in California specifically. So may more companies follow. There is a question for you, Bob, from Arjan van Vliet. What does Helix think about dynamic charging? Germany, Sweden, and the US are working on large-scale programs on this. Can you answer this, Bob?
So yeah, happy to do so. So if I may assume that dynamic charging is meant by controlling the peak demand of a charger, then yes, we are all in. And a good example is that, for example, the project we just shown in Amsterdam, we actively work together with the Mobility House, which is based in Silicon Valley, that we actively control dynamic, and as you call it, with dynamic charging, the peak demand of the specific operation. So peak demand is just one to control cost, more or less, or the impact on the grid. But you can do so much more, and frequency regulation are actually supporting the grid when an emergency is somewhere else at the grid. And I think, yeah, we're actively pursuing. We have many pilot projects already ongoing, but not explicitly put on the internet, as we want to gain first some experience. But yeah, they're definitely great partners to work with, also for you guys out there. And if we can help to facilitate that then we're definitely happy to do so. And I see the screen is still on my contact details, so please reach out to me.
Perfect. Thanks, Bob. Great presentation. In the meantime, also an answer for Spike was answered. They are also developing doing one project for aviation, electric aviation. So that's interesting to know for all that. I couldn't see that answer in the chat. We're moving on to BorgWarner, to Andrea. An American company that will tell us more about how that side of the battery market. I'm very interested in your story, Andrea. Please, the floor is yours.
Yeah, thank you very much. Good morning, United States. Good afternoon, Europe. Here, yes, please you can get the next slide. Barry, I'm going to introduce this argument, so a short presentation of the company, and a marketing overview on commercial vehicles, either both on-road and off-road application, and then the strategy that BorgWarner has to approach the battery market and the product that we developed to answer to the market needs. Next slide, please. Yes, thanks a lot. Very fastly, BorgWarner as a company of 29,000 employees spread all around the world, mainly in the three main regions, spread in 67 locations and in countries, and with a turnover consolidated of more than $10 billion. Next slide, please. Yes, we are divided into the three main regions, as you can understand, and also our market share as more or less reflects this, this spread. We are divided in four main business units, each one taking care of different products. BorgWarner starts as a very well-known company for mechanical parts, but made a lot of investment to enter into the electrification world. And what we're doing is not to reinvent the wheel, but we cooperate, acquiring or starting a joint venture with companies that already have the know-how in the market of products that are in line with our markets. Next slide, please. So we are mainly focused, of course, on passenger cars and light vehicles, but we have a very high interest on the commercial vehicle. The three segments: combustion, hybrid, and electric. And here you can see just a small list of the products that we can provide. But we can move from trucks to bus to all the construction vehicles and agriculture. Next slide, please. This is an overview of the market, what we believe is the market from our view. And on the left side, you can see the growing, that is quite interesting in terms of gigawatt hour, spread in several regions, and also spread in the years from today, 2020, up to 2025. And on the right side, you can see the spread between the several class of vehicles, and that's very interesting to understand where the main part of the market is occupied by the buses. So e-buses is really one of the main big investments, but even the class 7 and class 8 products are very interesting. Next slide, please. Also, not negligible, the approach for the construction of highway market, where we divided the study into agriculture, construction, and material handling. As you can see, material handling is already a mature market, so we decided as a company to focus more on the agriculture and construction, even because the products that we have is more definitely in line with the heavy-duty application and with a very high energy density. Next slide, please. Due to this market analysis, we defined and decided to find a company to work with in the market, and we defined a solution with a Californian company called Romeo Power Technology based in LA, and we believe that the power collaboration will bring us really very in a top position in the market, because Romeo Power has a premium technology, very high energy density application and product, so with the longest range and fastest charging time. They have inside a very huge engineering capabilities and expertise, while BorgWarner, of course, has a strategic global manufacturing footprint, so we can build our products already in our facilities, more or less wherever it's needed all around the world. We are recognized as a high technology and quality manufacturer, and we have a good customer portfolio and good relationship. Next slide, please. This is the main module that we have off the shelf available since now almost a couple of years, actually, together with Romeo Power. And it's a product that is already on the road, tested in a considerable amount of vehicles, and above all, e-trucks in North America with some of the main OEMs. This is a product that uses cylindrical cells with energy density that used to be 208 watt-hour per kilogram, but is going to be increased sooner with the new releases. And very, very fast charging, considering that there's an application for with energy cells. The application are several, all batteries powered and plug-in hybrid vehicles, definitely, for sure. Next slide, please. I want to show a little bit where we are and where we are going as a company from the module roadmap, and then later on from the battery product, from the battery pack product. So we can provide the market only the modules, we can provide the modules and the BMS, we can provide also the battery pack. The module itself starts with a 10 kilowatt-hour module called Hermes. It's water cooled. But it's going to see on the left side, you see the chemistry that we're using, and it's very nice because it's very modular. So it will be very easy to exchange the cells with new releases of cells with higher energy density, and the design is ready for a new product. The same story for the cell format. We started with cylindrical, where we're now closing and starting a new project for with pouch cells. On the product itself, we have the Hermes module that is water cooled with a cold plate at the bottom, but we're already designing and preparing product with a double side air cool. So with a one cool plate and the cells on both of the sides of the plate, so in order to increase the energy density. On the other side, also we're increasing the power density. We already have some prototypes of submerged technology. So well, the cells are completely submerged in the cooling liquid, and this allows to decrease basically the temperature gradient between bottom and top of the cells. And also we are starting the blue ice phase, where we are going to eliminate more or less the temperature gradient between in and outlet of the module. Next slide, please. On the pack, we have already developed some packs called Orion packs. They are tower packs as architecture from several capacity already available on the market, but we can also design a customized pack also for a specific application. On the BMS, we have already our own BMS, basic BMS, very flexible, that can combine a lot of functionalities, but we're implementing much more to be released in the next years about ISO 26262 or AutoSAR certification that is quite required in the market. On the pack architecture, we are also developing tunnel pack, mainly for pouch cells, and flat packs, also with Hermes modules. Next slide, please. And here is a kind of technology roadmap of the pack. So we are developing flat packs, 60 kilowatt hours, but also a double layer flat tower packs. As you could see, we have 30 kilowatt, 60 kilowatt hours packs, but we are developing even bigger packs up to 720 kilowatt hours packs. Next slide, please.
1 minute left.
Yes, I'm almost finished.
Perfect.
I just want to show that we have in-house a lot of engineering capabilities. On the left side, you see what we're doing in terms of simulation. So on the main segments, thermal, mechanical, BMS, and also we have a team with a deep knowledge of the cells available in the market. On the right side, you see what we can do in terms of simulation. So safety testing, This is the main driver of our designer, because all our designer is single test fault tolerance. We can do a lot of testing in terms of reliability testing and a validation of the module and of the whole pack in-house. We have deep analysis on materials and processes and very good relationship with a lot of self-supplier to work with. Next slide. Firstly, this is just an overview of Morse. So that is the business unit where I belong to and taking care about the batteries. So not all Borg Warner, but just one of the divisions. And as you can see, we already have facilities in Italy, in our Lugo, that has been selected for production, producing batteries in Europe. But we also have in Poland, and in the United States there is Los Angeles, where the joint venture has a seat, but there is also a production line. But we also have El Salto in Mexico and Ithaca on the other coast. Next slide, please. Yes, available for Q&A. So Rutger, to you.
Perfect. Thanks, Andrea. So first of all, to take away the confusion, for some reason your slides got mixed up with the ones of Heliox. So the background continuously shows Heliox rather than
yeah, right.
Warner. So my sincere apologies, of course, to you. And for the others, this was not Heliox presenting, but Borg Warner. We had Bob from Heliox earlier already. So a question I have for you, Andrea. You are situated in Italy, you mentioned.
Right.
What activities do you employ specifically here? Do you also develop the packs here in Europe?
No, at the moment, the development and the R&D is completely based in California. Here in Europe, we have the sales structure, the application engineer. That's actually the bridge between the R&D and the customers in Europe, and we have a team for the manufacturing.
All right.
So, right. No, not the real development at the moment.
No. Okay, but for the European and especially the Dutch companies, it's for different applications, as we saw in your presentation. It's possible to get in touch with the office here in Europe best, and then develop specific modules that meet their demand.
It's definitely possible. So I warmly invite you to be in contact with me if you have any more specific question. And we are already cooperating with some Dutch companies in order to start some very interesting activities in this market, in this specific market, actually.
Perfect, very, very good. Then perhaps you can be a bridge for us towards America, and the same way American companies also to the Netherlands in building these relationships for future battery development. We are going to the next presenter. This will be the last presenter as well. It's from Urban Mobility Systems, UMS. Bert van Mil is right next to me, and the floor is all yours, Bert.
Yeah, thanks very much, Rutger. First of all, thanks very much to the consulate and all others involved in the organization of the event, and good day and welcome to all participants. So, short introduction of Urban Mobility Systems today. My name is Bert van Mil, Chief Operating Officer of Urban Mobility Systems. And right, you see the team, which is expanding on a weekly basis, I would say. So this is an old picture. Next slide, please. So who we are and what do we do? So we're founded in 2016, relatively new company. In the current form as we are today, we started in 2017 with providing practical solutions. I think that's really the key word. We see a lot of development. I think offer deployable solutions for full electric commercial transport of people and goods in, I think I have to add an urban environment. So for now, we focus on the inner city, mainly on the inner city traffic. So the management team consists of senior people in the automotive environment, from reputable OEMs and first years. Next slide, please. So obviously, I think we all recognize the trends. Those people in the call the trends which are in favor of the business model of urban mobility systems are obviously the carbon dioxide footprint, so the climate, urbanization. So the estimation is by 2025 there'll be 40 cities across the world with more than 10 million inhabitants. So it's a huge population on a very in urban built up areas. Again, with the need for a better air quality in those built-up areas, and obviously the technology, not just artificial intelligence, but also the battery chemistry and battery technology has enabled much more than was possible 5 or 10 years ago. So we see a huge boost in the potential and in the capabilities of the current battery technologies, which enable us to do what we do today. Next slide, please. So where the core business consists of 3 parts really. So we see what we do is we develop our own battery electric vehicles, again for the transportation of goods and people in the inner city. So that's the picture you see on the left hand side, where you see UMS brand. So those are vehicles for the best part developed and constructed by Urban Mobility Systems. Then another part of what we do is another pillar of our business is the electrification for third parties, so the electrification for OEMs who are predominantly busy in the dependent on diesel for propulsion in the industrial products. So we're talking about cranes, we're talking about backhoes, we're talking about industrial equipment, we're talking about telehandlers, those kind of products. That's another line of business that we're in, where we support normally the OEM with the electrification, where the product is being designed and developed by Urban Mobility Systems. We supply a electrification kit to the OEM, and normally the OEM markets and sells the electric tools on the market. So Urban Mobility Systems is not involved in the in the selling or the marketing process, but just in the supporting and supplying the electrification kits for the OEMs. With that comes a third pillar, and that's obviously when we got some customers with higher energy demands for charging their vehicles. We can supply either charging solutions or buffering solutions in the form of a power box, where we buffer, where we can slow charge during the day. We can buffer the energy, and then in the evening when the units need to be charged, there's a buffer which reduces the strain on the grid, and maybe the risk of overloading the charge capacity at the OEM side or at the final customer end. Our customers consist of, again, transport operators and industrial vehicle OEMs, also fleet owners or fleet operators for public transport, and of course construction and real estate companies. Next slide, please. So our mission. So what do we want to do? We want to contribute to the acceleration of the energy transition. 3 keywords here to mention: quality, scalability, and it needs to be economically viable. So what we have now with the sudden strong rise of the industry, we see a boom in projects where sometimes the projects are driven by subsidies that are available. Yep. Subsidies that are available. We want to make sure that the solution that we provide are also viable without any subsidies, so that they're economically viable even at that time when the subsidies might go away. What we do is we design, develop, and manufacture, again, our own vehicles, and the common denominator of all those vehicles is the construction material that we use, which is a lightweight glass fiber reinforced polyester sandwich composite body construction. Next slide, please. So one big issue is the weight. If you can advance one slide. Oh, can you? Sorry, one back, please, because the titles don't come. So one big issue obviously is the weight. Passenger car, that's the worst case scenario where the payload is on average under 30 kilos for 1,300 kilo vehicle. So actually it's only 10% of the vehicle weight is usable payload. In light commercial vehicles, we go to a slightly better scenario, but with one of the solutions that we provide, which is called the Urban Mobility Solution, based on Nissan E and V400 with a composite trailer behind it, we come to about of a 50-50 share. So the trick here is that we use a one-piece glass fiber reinforced body, which is a very lightweight. This leads to a lower vehicle mass, so to a better ratio of payload and vehicle curb weight, and this enables again the acceptance of more payload, or with the same weight, total weight, a larger battery, which means more range. Next slide, please. Another common problem is the practicality of the electric vehicles. By use of the material that we use, and the composite material, we have a very high degree of form freedom. So we can build without a chassis. So building without a chassis means, okay, we can build a lot lower to the floor than regular vehicle, which is based on a vehicle chassis. This again allows, in case of people transport, superior economics, getting in and out of the vehicle or getting in and out of the bus or school bus. And in case of goods transport, you're much more flexible with regards to goods delivery. And next slide, please. So again, in summary, two main factors or two unique selling points or two unique features of the urban mobility vehicles. On the one hand, being the monocoque lightweight body, so that self load bearing construction. We don't need a chassis. So again, more payload or more batteries, which leads to a longer range. Next slide, please. Obviously, also with the certification, we see now in the market a lot of smaller electric vehicles, the LEVs, shuttle buses. Normally, those vehicles don't need to comply with the rules of the road, as they are valid for vehicles on the highway. The vehicles that Urban Mobility System supplies are compliant with all the regular requirements that are set to vehicles which operate on the highway. So that means all the legal restrictions, all the legal guidelines are handled or are complied with, and you can see some of those ranging from EMC to brakes to steering, etc. So these are all complied with, as opposed again to some of the lighter electric vehicles. Next slide, please. So what do we offer? Lightweight battery electric vehicles, last mile, inner city distribution, and mobility on demand. We see a shift from the larger buses to the smaller buses that we supply. Mobility, again, mobility on demand, with or without, supported by apps, is a business case that we see taking off, and where we can supply the product required for this solution. Also, the electrification of industrial vehicles. If there's industrial vehicle projects where the OEM has a lot of knowledge about the diesel propulsion, not that much about the rules and regulations on electric vehicles, that is where UMS comes in, and where UMS can provide the required knowledge and engineering capacity. What we're interested in finding also in the US is obviously customers, fleet operators. We have a school bus version of the UMS Mission. That's a 14+1 vehicle. So it would be a smaller school bus type. Transport operators and partners and investors in the US. Next slide, please. So these are the contact details. Thanks again for the attention. If you want to get in touch, these are the details, and we'd be happy to set up a conversation with you. Thanks again. Back to you, Rutger.
Perfect, Bert, thanks. So this was our last presentation. Hope you enjoyed this webinar. We saw both the Dutch way of working towards more green mobility, and we also saw the American and especially California, how they are developing new battery technologies and better battery packs and cells, and how CES is facilitating that. So these are the two organizations that everybody can get in touch with. There are no questions open yet, so I would like to end this webinar. Thanks all, and hope that we can further explore the synergies between California and the US and the Netherlands battery ecosystem. So thanks, and have a great rest of the week. Thank you all.